What do you think of when you hear the word computer? You probably picture your phone, a laptop, or a humming desktop with a glowing screen. But what if I told you the first computers had no screens, no electricity, and were made of brass gears and wooden levers? The question, what was the first computer, is trickier than it sounds. That's because the answer depends on what you decide a computer really is. Is it the electronics we use today, or is it the idea behind them? Let's travel back in time, long before electricity. Imagine a world where every single calculation had to be done by hand. Navigation charts for sailors, astronomical tables for scientists, financial ledgers for banks. All of it relied on rooms full of people, called computers, who did math all day. This created a massive problem. Humans, even brilliant ones, make mistakes. A single wrong calculation in a logarithm table could lead a ship astray, cause an engineering project to fail, or create a huge financial error. The work was slow, expensive, and dangerously unreliable. People dreamed of a way to automate this process, a machine that could calculate without getting tired, without getting bored, and most importantly, without making mistakes. This was the fundamental challenge that drove the invention of the computer. The desire wasn't for entertainment or communication, it was for certainty. The world was becoming more complex, and we needed a more powerful and reliable way to understand it through numbers. One of the earliest glimpses of this dream comes from ancient Greece. In 1901, divers discovered a strange, corroded lump of bronze in a shipwreck. It was the Antikythera mechanism, a device over 2,000 years old. After decades of study, scientists realized it was an astonishingly complex astronomical calculator. With a turn of a handle, its intricate system of over 30 gears could predict the positions of the sun, moon, and planets, and even the timing of eclipses. That complex natural cycles could be modeled and predicted using mechanical gears. The idea of mechanical calculation largely disappeared for centuries. It wasn't until the Industrial Revolution in the 1800s that the dream was truly reborn, thanks to a brilliant and notoriously grumpy English mathematician named Charles Babbage. Babbage was obsessed with the errors he found in hand-calculated mathematical tables. He saw them as a plague on science and engineering, and famously declared, "I wish to God these calculations had been executed by steam." He wasn't just complaining, he had a plan. He decided to build a machine to do the work automatically. His first design was the difference engine. The difference engine was a colossal mechanical calculator designed for one specific task, generating polynomial tables. It was a specialist, like the Antikythera mechanism, but on a scale never before imagined. It worked by using a mathematical method called finite differences, which turns complex calculations into a series of simple additions. This meant a machine made of gears and levers could produce flawless tables of numbers, hour after hour. Babbage secured government funding and began construction. The project was incredibly ambitious, requiring parts to be machined with a precision that had never been achieved before. But Babbage was a perfectionist and difficult to work with. After years of disputes and soaring costs, the funding was pulled, and the full engine was never completed in his lifetime. However, while working on the difference engine, Babbage had an even bigger idea, a truly revolutionary leap that marks the conceptual birth of the modern computer. He realized he could build a machine that wasn't limited to just one task. He envisioned a general-purpose engine that could be programmed to perform any calculation you could imagine. He called it the analytical engine. This is the machine with the strongest claim to being the first computer. It was never fully built, but its design contained all the fundamental components of the computer you're using right now. First, it had a mill. This was the calculating unit, the part that did the actual arithmetic. It was the ancestor of the CPU, or central processing unit, in your phone or laptop. Next, it had a store. This was a separate section where numbers and intermediate results could be held for later use. This was the world's first concept for memory, like the RAM in a modern device. Separating the calculation from the storage was a genius move. It meant the machine could handle far more complex, multi-step problems than any simple calculator. But the most brilliant part was how you told the machine what to do. Babbage borrowed an idea from the jacquard loom, a machine that wove complex patterns in fabric using a series of punched cards. Each card had a pattern of holes that controlled the loom's threads. Babbage realized he could use punched cards to feed not just numbers, but instructions into his engine. This was the invention of software. For the first time, a machine's function was not defined by its physical gears, but by a program that could be changed. One set of cards could tell it to calculate astronomical tables. Another could tell it to solve an algebraic equation. Babbage had designed a machine that could be repurposed for any logical task, simply by feeding it a new program. This is the very essence of a modern computer. Working alongside Babbage was Ada Lovelace, a gifted mathematician and the daughter of the poet Lord Byron. She was one of the few people who truly understood the profound implications of the analytical engine. She translated an Italian paper on the engine and added her own extensive notes, which were longer than the original paper itself. In these notes, she wrote what is now considered the world's first computer program, an algorithm for the analytical engine to compute a specific sequence of numbers. But Lovelace saw beyond the numbers. She speculated that if a machine could manipulate numbers representing quantities, it could also manipulate symbols representing other things, like musical notes or letters. She envisioned a future where machines could create art and music, a concept that was a century ahead of its time. She saw that the analytical engine wasn't just a number cruncher, it was a symbol processor. Sadly, Babbage and Lovelace were too far ahead of their time. The Victorian technology of steam and brass was not yet capable of building the complex machine Babbage had designed. His ideas were largely forgotten for nearly 100 years, until the dawn of the electronic age in the 1940s. When early electronic computer pioneers like Alan Turing and John von Neumann began their work, they independently rediscovered the core principles that Babbage had laid out a century earlier. So what was the first computer? The Antikythera mechanism was an amazing analog calculator. The difference engine was a powerful specialist, but the analytical engine was something more. It was the first design for a programmable, general-purpose computing machine. It embodied the crucial insight that the hardware could be separated from the software. This is the big idea. A computer isn't defined by its speed or its screen. It is defined by its universality, its ability to become any other machine through the power of a program. Babbage's engine was the first to capture this idea. It was a physical blueprint for a machine that could think logically. Today, whether you're opening an app, editing a photo, or sending a message, you are running a program. You are feeding a set of instructions into a store and a mill, just as Babbage envisioned. The technology has changed from gears to silicon chips, but the fundamental concept remains exactly the same. The architecture of his unbuilt machine lives on inside every digital device on Earth. So the next time you hold your phone, remember the frustrated mathematician and the visionary countess who dreamed it all up, powered by nothing more than steam, brass, and a truly brilliant idea.